Okay, so now onto the quotient rule, which is the rule for taking the derivative of the quotient of two different functions. And first, the incorrect method, which we showed for the product rule earlier. So for example, if we have f of x equals x to the 10th over x to the 5th, f of x would be simplified into x to the 5th power, and the derivative of that is f of x to the 4th, 5x to the 4th. And if we do the derivative incorrectly, which would be just the derivative of g of x over h of x, if f of x equal to g of x over h of x, the derivative would be equal to 10x to the 9th over 5x to the 4th, which gives us 2x to the 5th, which does not equal to 5x to the 4th, the correct derivative, which we found earlier. And so the correct derivative, the correct quotient rule is f prime of x equals g prime of x times h of x minus h prime of x times g of x divided by h of x squared. And if we take the derivative using this method, it would give us f prime of x equals 10x to the 9th times x to the 5th minus 5x to the 4th times x to the 10th, all divided by x to the 10th. And simplifying that equals 10 times x to the 14th minus 5 times x to the 14th over x to the 10th, which gives us 5x to the 14th over x to the 10th, which gives us 5x to the 4th, which equals to the derivative we found earlier. This is the correct definition. And now on to proving the quotient rule. If big F of x equals f of x over g of x, then if we find the derivative of big F of x, that would give us, in the limit definition, as h approaches 0, little f of x plus h over g of x plus h minus little f of x over g of x, all divided by h. And so if we multiply everything here by g of x plus h times g of x in order to remove the denominator, it would give us limit of h approaching 0 of f of x plus h times g of x minus f of x times g of x plus h, all over g of x plus h times g of x times h. And so if we split this into two limits, one of limit of h approaching 0 of 1 over g of x plus h times g of x times the second limit of h approaching 0 of f of x plus h times g of x minus f of x times g of x plus h, all divided by h. This is in two limits, and if we take the limit of this first part, it gives us 1 over g of x all squared. And so we'll keep this section and add it into the rest of it for later. And now let's focus on the second half. To this limit, we will add and subtract f of x times g of x minus f of x times g of x. So if we add that in here to the numerator, we get limit of h approaching 0 of f of x plus h times g of x plus f of x times g of x minus f of x times g of x minus f of x times g of x plus h. And if we rearrange these two and move the subtraction one to here and the addition one to that side, we will get limit as h approaches 0 of f of x plus h times g of x minus f of x times g of x minus f of x times g of x plus h plus f of x times g of x all over h. And so we can then split this into two limits and then factor out. So by splitting it into two limits, first we factor out g of x from this first part and f of x from the second part, and then we split it into two limits. G of x times limit of h approaching 0 of f of x plus h minus f of x divided by h minus f of x as the limit approaches h approaches 0 of g of x plus h minus g of x divided by h. And so as we can see here, the inside is actually just the limit definition of the derivative. So we can simplify that to f prime of x times g of x minus g prime of x times f of x. And if we take the 1 over g of x squared from before and multiply both of them together, it gives us the derivative definition, which is f prime of x times g of x minus g prime of x times f of x, all over g of x squared. And so on to examples of the quotient rule. If we have f of x equals x to the 4th plus 10 all over x to the 3rd, using the quotient rule, we would get 4 times x to the 3rd times x to the third minus 3x squared times x to the fourth plus 10 all over x to the sixth. And simplifying that, we get 4x to the sixth minus 3x to the sixth minus 30x squared all over x to the sixth. And simplifying, we get 1 minus 30x to the negative fourth. For our second example, it involves sine and cosine, two trig functions. And so by taking the derivative of that, we get cosine of x times cosine of x minus sine of x times negative sine of x all over cosine squared of x. And simplifying, that gives us cosine squared of x plus sine squared of x divided by cosine squared of x. And simplifying, that gives us 1 plus tangent squared of x. And that's all for today. Thank you.